In this lesson, we're going to be talking about how we can draw internal line tangents. Just like we had for external line tangents, the first scenario is when we have two circles with the same radii, and the second one is when we have two circles with different radii. The first thing we do is draw a construction line on which our circles are going to be drawn. Then we measure that distance, 110, which is the distance between the centers. We can mark it on this line. We can call this point A and this other one B. Then we can measure our radius, which is 20 millimeters, and draw it at A and B. Next, we're going to bisect the distance between A and B. We'll go to draw these lines. Now we have a point X. Next, we're going to bisect once more. This time we're bisecting the distance BX, or if you prefer, you can bisect AX. I'm going to bisect BX. We can call this point Y. Now, here's an important point that you need to always remember. Depending on how the internal tangent passes through these two circles, you might need to draw a semicircle at the top or at the bottom. The rule of thumb here is notice where the line tangent touches the circle that is nearest to this bisection. As you can see, since we've bisected BX, this bisection is near this circle. So if our line tangent is passing through like that, it means it's touching the top of this circle. Because of that, we're going to draw a semicircle such that it touches the top of this circle. However, if the line tangent was passing in such a manner where it touches the bottom of this circle, our semicircle would have to be drawn at the bottom like that. I'm going to stand at Y, open to X, which would give me the point B like that. Then I draw my semicircle. This point here, we can call point 1, is the point of tangency. And so we need to draw a normal from the center to that point of tangency. After we've done that, we need to transfer this line to this other center A. Or simply, we need to draw a parallel line to this line B1 at A. To do that, we're just going to use our set squares and slide them around such that we transfer this line at A. For line tangents, you need to be able to do this procedure of sliding effortlessly. Whenever you see me sliding the set squares, always know I've made this kind of setup. Sometimes you might not see both set squares, so you might just see one sliding. Usually you get into this problem where your set square is too large and hits your clip or cannot proceed like that. There are many ways in which you could troubleshoot this. The best is maybe using the other set square. This time when I slide, I'm sure it won't hit. Notice how I draw this other normal going downwards, because I know this is an internal tangent. There's no possibility that when my tangent touches this point 1, it's going to touch a point at the top of this circle. This point 2 here is the second point of tangency. Now I'm going to draw my tangent, which will touch point 1 and point 2. Next, I outline my circles. And there I have it, an internal tangent In the next example, we're going to try to draw an internal tangent where we have got two circles that have got different radii. In the next question, we're going to be drawing an internal tangent when we have two circles with different radii. The first circle has a radius of 35 millimeters. The second one has a radius of 30 millimeters. And as you can see, there's a difference vertically between the centers and also horizontally. Let's draw the centers of these circles and then see how we can draw an internal tangent in such a case. Horizontally, there's a difference of 120 millimeters. So I'll mark that distance first. Can label this point A and this other one B. B is not my center yet, it's just where my center lies. Then I can draw a vertical line at B. Make sure you are using a T-square if you want to do something similar to what I'm doing. I place my set square on the T-square, then I can draw a vertical line. This line is at 90 degrees to AB. At B, I'm going to mark 20 millimeters. That will give me point C. A and C are the centers of my circles. At A, I'm going to draw the circle with a radius of 35 millimeters. At C, I'm going to draw the circle with radius 30 millimeters. And also draw the vertical lines. Here we need a horizontal one at C. The next step is I join the centers of these two circles, which is A and C. After joining the centers, I'm going to bisect the distance AC. I now have a point X. I'm going to place my compass at X and draw a semicircle from A to C. Now, the next step is adding the smaller radius to the bigger one. If you can remember, the smaller radius was 30, which is the circle at C. So I can just get this distance from this circle. Make sure I've picked the right one. To verify it's the right one, just try redrawing through this circle. If you get the same circle, then you've picked the right distance. To add, what you can do is this: stand at this point, mark an arc like that. We can call this point 1. Then stand at point A, open your compass to 1. That's adding them. Then you draw an arc from 1 that cuts our semicircle that we are from drawing. We're going to look for a special intersection now. This intersection here, which we're going to call 2. Then we'll draw a line from A going through 2. Once you do this, you're going to have a point here, which you can call 3. In fact, let's call it P. P is the point of tangency. Next, we're going to draw a parallel line to AP at C. And I'm guessing you know what we're going to do next. We get our set squares and then slide this line to C. And we know this is an internal tangent we're drawing, so we don't expect that the line we're going to draw at C will also go upwards. It will go downwards like that. I make sure I hold this other set square very firmly, then I slide. When my set square is at point C, I draw a line like that. And now I have another point here, which I can call Q. P and Q are points of tangency. Hence, we can draw a line through P and Q, which is going to be our tangent. Next, we outline our circles and we have drawn our internal tangent. Notice these radii are different. Even though they look very similar, if you were to try what we did with circles that have got the same radius, you will find the method won't work, even if there's just a slight difference. If you want to draw an internal tangent that goes through in this way, what you have to do is do the same procedure but with the semicircle at the bottom. So you have a semicircle like that, you bisect, then do the addition, but this time instead of taking the arc that we drew with the radius A1 like that, you will instead make this arc come downwards, and then everything stays the same. I'll emphasize that you know these construction methods by heart. How you do that is just practice these methods oftenly. Aside from that, make sure you do a lot of questions.